All right, we're going to go through the three different forms that you see a quadratic equation that appears that you're going to be asked to graph it. The three forms are standard form, intercept form, and vertex form. We're actually going to go through all three forms. They're in section 4.1 through 4.2, 4.3 in the Algebra 2 book. And really, we don't ever want to say, oh, just know how to graph it in one form. We want you to know how to graph all three forms, because if you see it in one of the forms, they each have their benefits, and they each have a good different way of graphing it. So let's start with standard form. All right, we're in standard form, and standard form is when the equation is given to you in y equals ax squared plus bx plus c. And here's an example of y equals negative x squared minus 4x minus 5. Your first step is to find the axis of symmetry. So in this particular problem, I'm going to work to find the axis of symmetry. I'm going to take the negative of my b, so it's the negative of a negative 4 here, and I'm going to divide it by 2 divided by my a. My a is a negative 1. So the negative of a negative 4 is positive 4. 2 divided by negative 1 is negative 2. So I found my axis of symmetry to be negative 2. Now what that means is x equals negative 2 is my axis of symmetry. Okay, let's talk about that. Let's show this on the graph now. So I have my graph here. I want to show my axis of symmetry. X equals negative 2 is this line right here that I just put in green. That's my axis of symmetry. An axis of symmetry says that what's ever on the right side of that line is going to look the same as what's on the left side of that line. So we know we're going to have the same on the left and the right. So that's my x equals negative 2, my axis of symmetry. I'm going to draw my x equals negative 2 there. The next step is I need to find my vertex. Now the process of finding the vertex, I need to move things down here a little bit. Sorry, guys. Process of finding the vertex is that I am going to plug in my x value, because along this axis of symmetry, along this green line, somewhere is my minimum. The reason I know that there's a minimum and not a maximum is because my a here is a negative. My a is a negative 1, and so I know I have a minimum because it's going to go upside down, or maximum, excuse me, because it's going to be upside down. So I need to plug in that x value into my original equation. So into this y equals negative x squared, I'm going to plug in negative 2 for x squared. And here I'll put the negative 2 minus 5. So here I'd have the negative of negative 2 squared, the negative of 4 here, minus negative 4 times negative 8. It's actually going to be plus 8 minus 5. So this turns out to be positive 4, negative 1. So what I know from just doing that calculation is that my vertex is at negative 2, negative 1. So along my graph I just had, negative 2, negative 1, right here, this point is my maximum value. That's my vertex. That's the highest point my parabola is going to get at. The next step is to say to yourself, okay, I know I have a point, negative 2, negative 1, that's on my parabola. Let's see what happens to that curve as it curves around the parabola. So I also want to look at 2 points to the right, negative 1 and 0. So what I want to do is I kind of want to do my work over here. So I said, okay, at negative 1, I want to know what is y. I'm going to kind of make a place for my work here. Y equals the negative of negative 1 squared minus 4 times negative 1 minus 5. So it's going to equal the negative of 1 squared. Negative 1 squared is 1. It's going to be plus 4 and then minus 5. So that's actually going to equal here negative 6, negative 2. At 0, it's a little easier because y would equal the negative of 0 squared minus 4 times 0. That's going to be 0 minus 5. It's just going to be negative 5. It's just going to be my c, and that's usually what happens, or always what happens. So we need to plot those 2 points on our graph and say, okay, what happens with our graph? So I'm going to plot the point negative 1, negative 2. Here's that point. Here's the point negative, or 0, negative 5. So as this graph goes to the right, that's pretty much what happens. On the left-hand side, what's nice is we have a mirror image. So you kind of can see how I can really quickly look and just make my mirror image. So right there is my points here. I don't know if that's happening. Where? All right, right here is my parabola. Let's look at another example for us here. All right, another example, same type of problem. First we have to say to ourselves, what is our axis of symmetry? So we're first going to do our negative b over 2a. Negative b would be positive 8 over 2 times 2. So we have really 8 over 4. Our axis of symmetry here is x equals a positive 1. Now, we're going to go ahead and find, is that going to be our max or our min? It's going to be a minimum because it's going up because we have a positive a value. So it's our minimum value that we're going to be looking at when we try to find our vertex. Next thing I'm going to do is find my vertex. That's where I plug in this value for my x. So here, y equals 2 times 2 squared minus 8 times 2 plus 6. So y would equal 2 times 4, or 8, minus 16 plus 6. I get an answer there of negative 2. So we found our vertex to be the point positive 2, negative 2. All right, so what we found is my axis of symmetry is at positive 2. Here's my positive 2. My vertex is at positive 2, negative 2. That's my minimum value. And then the last step is I need to find out 2 more values to the right of that. So I'm going to try 3 and 4. Usually I just go to the right. I could have just as easily gone to the left and found those 3 values. So at 3, I'd have 2 times 3 squared minus 8 times 3 plus 6. 2 times 3 squared is 2 times 9. 2 times 9 is 18. Minus 24 plus 6. This actually turns out to be 0. When I do 4, let's do 4 down here. 4 squared minus 8 times 4 plus 6. 2 times 4 squared is 2 times 16. 16 is 32. 8 times 4 is 32. And then we have plus 6. This turns out to be 6. So my other points here were 3 and 0. Here's 3, 0. 4 and 1, 2, 3, 4, 5, 6. 4 and 6. So you can see very quickly how my parabola shapes up. Mirror image on the other side. There's my parabola. So I can graph it pretty quickly when you know the steps. Let's talk about the next way we might see this. Vertex form. All right, so when we're given vertex form, you know all that work we just had to do to figure out the vertex? We don't have to. And that's why it's good to know, oh, I'm given vertex form. I can just look at it and say, there's my vertex. So I can just look at this and say, there's my x in my vertex and my k in my vertex. It's still about the a as far as whether it opens up or opens down. Whether a is negative here, if it's positive, it opens up. If it's negative, it opens down. So let's look at an example here. So first thing I see when I look at this, I see a negative a right here. And so I know it's going to open down. So that tells me, okay, I'm going down. This tells me my x is a negative 2. Remember, it's opposite on the inside of the parentheses. This tells me my y on my vertex is a positive 5. It's actual on the outside of the parentheses. Okay? So, plotting the vertex here, my vertex, I can look at this and just say 2, 5. All right? I know here my a is my negative 1/4. The next thing here is, okay, how does it curve? So we know exactly where our vertex is. We need to go from there. What I like to do is the same thing I just did for the standard form. Think about my x and my y. I know that negative 2 and 5 is 1. I'd probably try negative 1 and 0 here. And I would just work it out. So negative 1, I'd have negative 1/4. I'm going back to my original equation, equals negative 1 plus 2 quantity squared plus 5. So I have negative 1 here, plus 2 is 1 squared. So I'm getting negative 1/4 plus 5. So here I actually get kind of icky, 4 and 3/4. When I plug in a 0, negative 1/4 times 0 plus 2 squared plus 5 there. I get 2 squared is 4. Negative 1/4 of 4 is negative 1. Here I get a 4. That's a little bit better. And then I could draw the equation. I'm going to show you, sorry about that. I'm going to show you an example here. Let's start with a new example of the whole process where we have a graph. Right away, I can look at this and say, wow, I know my vertex. My vertex is at -2, +5. Oh, that's what we just had. Sorry. I guess I didn't realize I had 2 of the same here. So we have to plot the points 1 and 4 3/4 and 0 and 4. So let's do that. So we have to plot the points 1 and 4 3/4 and 0 and 4 was what? Let's see if I can remember in a minute there. Yep, 0 and 4. All right. So let's plot those points. We have the vertex at -2, 1, 2, 3, 4, 5. There's my vertex. I know it goes down because it was a -1/4 for my A. The next one was 1 and 4, 1, 2, 3, 4, and 3/4. So it doesn't go down very quickly. The next one was 0 and 4. Here's 0 and 4. And so we know it kind of goes down slowly here is really what this told us. I could keep finding values to get really exact. I'm not that worried about being that really exact here. Okay. The last form is intercept form. So you should be able to look at this and get a little bit more information. The opening up or down for your graph, it all depends still on the A. That's the nice thing. So that A is always telling us, is it opening up or opening down? Axis of symmetry, and I'm going to show you this a little bit here. I need to show you a bit more visually. So I'm actually going to move on. Let's look at this one. So when I look at this, what I know when I first look at this one, this here, right here, this part, tells me that -3 is a solution, or that the point here of -3, 0 is on our graph. This tells me that the point 1, 0 is on our graph. So what it is it's telling us, that one's telling us where are the x-intercepts for this particular graph. So let's look at that. Here's the point -3, 0. Here's the point 1, 0. That's where this graph goes through my x-intercepts, or my x-axis there. We don't know how it goes. We don't know if this graph goes like this, all right? This graph could go, instead of that, it could come down and it could come lower. It could come really low. It could be really high. We just don't know how it looks, though. And so that's what we have to decide here, is how does it look? And that's what our process is. What we do know is that it has to go, oh, actually, and I had it wrong. I had it upside down. We know it has to go like this. I'm sorry about that. Because of the positive A, I know it has to go up. But again, I don't know how. So that's what I'm going to kind of look at and say, okay, how do I figure out how the graph goes? So I need to find the middle value between these two dots. And so that's what you saw before, is kind of an equation about your P's and your Q's. You're really taking these two numbers here, you're adding them together, and you're dividing by 2 to find the halfway point. Our halfway point is -2 here. Wait a minute, wait. 2. Oh, I know what I did wrong. I didn't do that. Yep, sorry, made a mistake. And I'll make a change. And that would be -2 divided by -2, or +2. Our halfway point is -1. Now this makes sense. Sorry. All right, so our halfway point here is at -1. What I know is that's my axis of symmetry. That's where that vertex has to appear. And we know it has to be somewhere below here. So what we do, a lot like when we found that axis of symmetry in the standard equation, we plug it in. We say, okay, what is y when we have x is a -1? All right, so here we'd have 2 times 2 times a -2. Turns out to be -8. So we have here 1, 2, 3, 4, 5, 6, 7, 8. This point right here is our vertex. Our vertex is at